We're now going to have a look at adding and subtracting fractions. Let's start with 1/5 plus 2/5. Here I have 1/5 and here 2/5. If we add them together, we have 3/5. So what I've done is added the numerators of the two fractions. So 1 plus 2 gives me 3/5. Let's have a look at another example. Let's say we have 1/8, another 1/8, and 5/8. So in the same way, I have 1/8, another 8, so that's 2/8, and then 5/8 to add on. So that gives me a total of 7/8. If we're adding like fractions, so the fractions are all of the same size, here we had 8ths, so all the denominators were 8, we can just add the numerators. Here the denominators were 5ths, they were the same size, so we could add the numerators. Subtraction is very similar. Let's have 5/8, and this time we'll take away 3/8. The denominators are the same, so we have the same type of fraction, so we can just do 5, take away 3, gives us 2/8, and if we put that into its lowest form, that's 1/4. Let's have a look at another addition one now. This time, let's have 3/5 plus 4/5, and when we add them, 3 add 4 gives us 7/5. So we've added two proper fractions, and they've added together to give an improper fraction, a fraction that's larger than 1, and if we write it as a mixed fraction, 5 goes into 7 once with 2 left over, so that's exactly the same as 1 2/5. Okay, let's look now at what happens when we have fractions where the denominators are not the same. Let's say we have a half plus a quarter. So let's have a look. We have a half plus a quarter. We can add them together, but what do we end up with? How can we describe the fraction that we have? Well, we know that a half is the same as 2/4. So if we change our half, we find an equivalent fraction of 2/4, and then add our quarter. We're now in the situation where the denominators are the same, so we can simply add the numerators. So we get 3/4. Let's have a look at 3/4 plus 3/8. The denominators are not the same, so imagine now we have 3/4 and we have 3/8. What we need to do is to make these into 8ths. Let's go back looking visually again. There's our 3/4. And there's our 3/8. Well, in fact, visually we can see an answer straight away. We've got a whole one here and 1/8. But let's actually see what is happening numerically here. We can't turn eighths into the quarters very easily. If we've got two of them, yes, that's a quarter. But we've got this one left over. But what we can do is turn our quarters into eighths, because 2 eighths fit very nicely into a quarter. So what we have, instead of 3/4, is 2 eighths there, 2 eighths there, and 2 eighths there. So we have 6 eighths plus our 3 eighths. Now again, we have fractions with the same denominators, so we can just add the numerators. So we get 9 eighths, which we saw at the beginning is a whole one with 1/8 left over. Now here we've used fractions where they're in the same sort of family, because eighths fitted exactly into quarters. Quarters fitted exactly into halves. What happens when it's not quite so convenient? Well, let's have a look at a half plus 1/3. So what we're wanting to add together is a half plus a third. Now, if we tried to turn the half into thirds, we'd have difficulty because it doesn't fit a whole number of times. So what we need to find is a fraction, the denominator, that fits into thirds as well as into half. And in this case, that fraction is sixths. We can fit 2 sixths into our third, and our half is 3 sixths. So we're finding an equivalent fraction for our half is 3 sixths, and our third is 2 sixths. So again, with the denominators now the same, we can just add the numerators, and we see we've got a total of 5 6. 3 plus 2 giving us 5. Let's try another one now. Let's look at a quarter plus 2/5. Now, we need to find a number for our denominator that 4 is going to fit into, so it can be divided into quarters, and that 5 is going to fit into. Well, let's have a look at some numbers that 4 and 5 fit into. Let's start with 4. Well, 2 4s are 8, 3 4s are 12, so these are all numbers multiples of 4. 16, 20, 24, and so on. And let's have a look at numbers that 5 fit into. There's 5, 10, 15, 20. I can stop there because I've now found a common number, a one that's in both the 4s and the 5s. So 20 is our common denominator. So we're going to change our quarters into 20ths. Well, how many did we need? 1, 2, 3, 4, 5. So 5 20ths is the same as a quarter. And our 2/5, well, we needed 1, 2, 3, 4 20ths make 1/5, but we've got 2/5, so we've got 8 20ths. So in total, now we've got the denominator the same, 8, add 5 gives us 13/20. Let's have a look at this now numerically. We've done it by thinking about it, by perhaps visualising it in our heads. Let's have a look numerically at what's actually happening. There's our quarter plus 2/5. How did we arrive at this 20? Well, we were looking for a number that both 4 and 5 fitted into, a common number. So what you could say we did here is actually multiplied the 4 and the 5. 4 goes into 20 5 times. So what we did is multiplied 4 by 5. Now, with our fractions, whatever we've done to the denominator to find an equivalent fraction, we must do the same to the numerator. So we had to multiply this one by 5 also. Our 2/5, we multiplied the 5 by 4 to make 20. Whatever we multiply the denominator by, we must multiply the numerator by. And our numerator was 2. So we have to do 2 times 4. And this is how we arrived at our 5/20. 1 5 is 5. 4 5s are 20. 2 4s are 8. Sorry, that's a plus. And 5 4s are 20, giving us a total of 13/20. Let's have a look at subtraction. This time let's have 3/4 take away 1/6. So again, we're looking for numbers that both 4 and 6 fit into. Let's have a look at our 4s. 4, 8, 12, 16, 20, 24, and so on. And our 6s, multiples of 6, 6, 12, 18, 24, and so on. Now, the reason I've written so many is that I want to point out to you that there might be more than one common pair. 12 is a common denominator. Both 4 and 6 fit into 12. But also there's another one here, 24. And both 4 and 6 fit into 24. And in fact, if we multiply 4 and 6 together, we get 24. But as you can see, in this case, that's not the lowest common denominator. It's not the lowest number that's common to both of these denominators. We want to use the lowest one, because if we don't, we then need at the end of the calculation to actually reduce the fraction to its lowest form. And it's much easier to deal with smaller numbers, so we try and find the lowest one. So we want to write our 4, we want to turn it into an equivalent fraction with 12 as the denominator. Well, what have we done to 4 to make it 12? We've multiplied by 3. So we must multiply the numerator by 3. What have we done to our 6 to make it 12? We've multiplied by 2. So we must multiply our numerator by 2. 3 3s are 9. 4 3s are 12. Take away, once 2 is 2. 6 2s are 12. Now our denominators are the same, so we can simply subtract the numerators, giving us a result of 7/12. So, what we're doing when we add and subtract fractions is we need to make sure that the denominators are the same before we do the addition or the subtraction. If they're not the same, then we need to find the lowest common denominator between the fractions and then find equivalent fractions, and then we can do the addition or subtraction. What we need to look at now is when we have mixed fractions. Let's say we've got 5 3/4 and we're going to take away 1 4/5. How do we deal with that? Well, the first thing that we need to do is to turn them into improper fractions. We need to make them so that they're all over, in this case, quarters, and with this one, fifths. Then we can do the process that we've just done, finding common denominators and actually doing the subtraction. So, first of all, we need to find out how many quarters we have here. Well, we've got 5 whole ones. We want to make them into quarters, so we multiply by 4. And then we're going to add the 3 that we've got there. So that's how many quarters we have. And we're going to take away 1 4/5. So 1 multiplied by 5, that's how many fifths are in a whole one, plus the 4, and that's how many fifths we have. 4 5s are 20, plus 3 is 23 quarters. Take away, once 5 is 5, plus the 4 is 9 fifths. Now we need to find the common denominator of 4 and 5. Well, as we found before, that's 20. What have we multiplied 4 by to make 20? That's 5. So we have to have 23 times 5. Take away our 20ths. What do we multiply 5 by to get 20? Well, that was 4, so 9 times 4. So 23 times 5, 5 20s are 100, 3 5s are 15, so that's 115 20ths. Take away 4 9s are 36 20ths. Now our denominators are the same. We can simply subtract the numerators. 115 take away 36 is 79. So we have 79 20ths. And usually if our question is given in terms of a mixed fraction, then we ought to give our answer in the same form. So 20s into 79, well 20 20ths make 1 whole one, and we've got 3 whole ones there, 3 20s are 60, and then we've got 19 20ths left over. So the answer is 3 and 19 20ths. Let's have a look at one more example. This time using 3 fractions. So 1 3/4 plus 6 2/5 plus 5 halves. So we've got a mixture here of mixed fractions and an improper fraction. Well, as before, the first thing we need to do is to turn these mixed fractions into improper ones. Here we have 1 whole one. We need to turn it into quarters, so we multiply by 4 and we add the 3. That's how many quarters we have. And then we add now 6 whole ones. If we turn them into fifths, we multiply by 5. We add the 2, and that's how many fifths we have, plus our 5 halves. Once 4 is 4, plus 3 is 7 quarters, plus 6 5s are 30, plus 2, 32 fifths, plus 5 halves. Now this time we need to find common denominator of all three of these denominators. Now, it's easier to think perhaps of the largest one first. So if I think and count up perhaps in fives, 5 obviously is not common to these two. 10, well 2 goes into 10, but the 4 doesn't. So let's keep going. 15, that's no good. 20, yeah, 5 goes into 20, 2 will go into 20, and so will 4. So 20 is going to be my common denominator. So let's just write all the denominators in. So what did I do to 4 to get 20? I multiplied by 5. So 7 must be multiplied by 5. What did I do to 5 to get 20? I multiplied by 4. So I must do 32 times 4. The numerator and the denominator must be multiplied by the same number. And finally, what did I do to the 2 to get the 20? I multiplied by 10. So I must multiply the numerator by 10. 7 5s gives us 35, plus 4 32s. 4 30s are 120. 2 4s are 8, so it's 128 20ths, plus 50 20ths. And if we add these all together, we get 128, 178, 213 20ths. And again, let's turn that back to a mixed fraction. How many 20s, how many whole ones are there in 213? Well, 20 times 10 gets us to 200, so that's 10 whole ones and 13 20ths left over. So if we add 1 3/4, 6 2/5, and 5 halves, we get 10 and 13 20ths.